Hi there. I'm pretty sure your curiosity has once caused you to get a past exam paper, and obviously you checked it to see what kind of questions are asked in an exam. Now, I assume you came across a question like this. A question where you saw some shapes, some arrows on that shape, and some letters on that shape. You are asked to find some things that maybe you never knew how to find. This is Z Online School, and in this video, we'll be looking at the introduction to vectors. We're not going to do this in any way, but we're going to do it in a systematic way. We're first going to look at the basics of vectors, column vectors, position of vectors, and at the end of this video are some bonus tips that you can look at to improve the way you handle vectors. The first thing we're going to look at are the basics of vectors. Basics of vectors are just those simple things that you need to know about vectors before we get into deep or a bit of complicated things. The first thing is the definition of a vector. A vector is simply just a quantity that has got both magnitude and direction. By magnitude, we just mean size. Examples of vectors can be the following things: displacement, and as you can see, acceleration, force, and velocity. Apart from the definition of a vector, you should also know how vectors are represented. If you surely looked at an exam paper and saw something about vectors, you should know how vectors are represented. We'll have two letters and an arrow on top. These two letters in this representation mean the starting point and the ending point. The arrow shows us the direction of this vector. Under the Zambian syllabus, it's rare that you find this arrow changing direction. However, these letters might be switched. Let's say we've got 2 points A and B. If a vector were to be drawn to represent what we've written as AB on top here, this is what it means. The starting point of this vector is point A and its end point is point B. Let's say this is displacement. So there's a displacement from point A to B in a direction towards the right or towards the east. This is how vectors are represented. And if you see anything like this in a question paper, that question will be likely about vectors. Now, let's talk about column vectors. Column vectors are another thing that you need to know about vectors right from the start. These are vectors which are represented in the form of a column matrix. Therefore, they will look something like this. If we've got a grid which has got some points, let's say we've got points A to D, we can find the column vectors of AB, AD, AC, and so on and so forth. In this example, we're going to be looking at the vectors AD, DB, and BC. When finding column vectors, what we do is just simple. We find the difference between the 2 points. As you can see, we're trying to find vector AD. Our starting point is A and our end point is D, which means our vector is starting from point A and going towards D. When we're given something like this here, when finding vector AD, we find the difference between point A and D, starting from A. So A will be like our 0 mark. Then we start counting towards our right until we reach the line on which D lies. As you can see, the only difference here is 1. So our top number here in our column matrix is going to bear 1. Now, if we go into our y-axis, we're going to see that we're going downwards. As you may know, on our y-axis, numbers increase as we are going upwards. Remember, our starting point is A, so it will also act like our 0 even on the y-axis. Therefore, D is on a position that is -1. This is the column vector for AD, and this is the column matrix which represents vector AD. We'll do the same for DB. Our starting point this time is D, and our endpoint is B. So we're going to find the difference in x between D and B. This will be our 0, or our starting point. So 1, 2. And in our y, you can see from D to B, we're going to have 1, 2, 3. Both of them are in the positive direction. Now it's time to look at BC. We're starting from B and we're ending at C. The difference in x is 4. 1, 2, 3, 4. Now it's going towards our left. Therefore, it will be negative 4. The difference in the y-axis is 4. 1, 2, 3, 4. And we're going downwards. So our value here will also be negative 4. This is how column matrices for column vectors are formed. If you understand this, it will be very easy to understand the next thing, which is about position of vectors. Now, under vectors, direction is very important. I want you to draw out these other vectors, dA, vector BD, and vector CB. These vectors have the same points as these we just did. However, the direction in which we are moving is different, which means the starting point and the ending point have been switched. What you observe is this: when we go in an opposite direction, our signs change. Therefore, in the case of AD, we're going to have a negative 1 on our top part here and a positive 1 on our bottom part. For BD, the same happens. These are vectors which have their starting point from the origin. So basically, they will start with O and then have another letter. Formation of position vectors is just the same as column vectors. If we had a grid here and we are told on this grid there are some points which are position vectors, let's say we had A, B, and C, we could find the position vectors for A, for B, and C. Bearing in mind that we'll be finding the position vectors, we should note that we're starting from point O, which is the origin. It's rare that in a question you'll be told you're starting from O. They'll just tell you A is a position vector. And therefore, when you hear the word position vector, you should know the starting point for that particular vector is the origin. And therefore, the representation will be similar to this. If we look at A, it's going to have 1, 2, 3. In the y-axis, the difference is 1. So it's the position vector for OA is 3, 1. Position vectors might also just be indicated as coordinates. So this 3 and 1 can be represented as 3, 1. We're going to do the same for OB and OC. You can see there's no difference in the x-axis, so it will be 0. In the y-axis, we've got 2. For C, we do the same thing. And we're done forming the position vectors for these 3 points. Again here, I want you to pay attention to what happens when we change the direction in which we move. You have reached the bonus tip section, and the first thing we're going to look at is the triangle law of addition. This principle is used not only in vector geometry, but also when we're looking at position vectors and column vectors. The triangle law is just simply a law that binds vectors that are making a triangle. If we have 3 vectors that are forming a triangle like this, let's say vector AB, vector BC, and vector AC, AB has a certain value, BC has also a certain value. If we add the vector AB and the vector BC, we're going to have the vector AC. So if we had A as the value here and B as the value here, vector AC is going to have A plus B. This is basically the triangle law of addition. However, there's another way in which you can think about it. Think about this triangle as a passage. We're trying to get to C. and our starting point is A. When finding the vector AC, we just think about a path that we can follow from A and arrive at C. The only thing is that we shouldn't use AC because that's the vector we want to find. Therefore, we're going to use the route A, we go to B, and then arrive at C. This is another way of thinking about the triangle law of addition. The next thing we're going to talk about is the addition of column vectors. Column vectors, as you may know, are vectors represented as column matrices. Therefore, when adding them, we just add them like normal column matrices. So, if we had the vector BC and the vector CD, adding these two vectors to find BC plus CD will just be this procedure. We get these two vectors, show them like this, the first vector plus the second vector, and then we add the elements in the same place. So this 4 and this -1 will be added together, this 5 and this +2 will be added together. Now, here we've got a positive and a minus. What you should always remember is that when you've got a positive and a minus, the minus always wins. If you're adding here, what happens is this positive sign will change to a minus sign. If it's multiplication, still the minus wins. So what happens here is it will be 4 minus 3, and that will give us 3. 5 plus 2 will give us 7. Therefore, our answer is 3, 7. This is how column vectors can be added together. The third thing you need to know about is the use of position vectors. We talked about them earlier in this lesson. Now, what is the real use of these position vectors? Well, position vectors bring about a formula that is very useful when we're handling vectors. This grid will be used to illustrate how this relationship comes about. However, what you only need to know is about the formula that will be derived. Let's say we're asked to find AB and BD. If we're given that the position vector of A, B, and D are 0,4, 6,8, and 2,2 respectively, we can find AB and BD without using any diagram. However, in this particular question, I'm going to try to illustrate what we'll be doing here on this diagram. This word respectively simply means as this information is mentioned, is the way it's distributed to these letters, meaning 0,4 is for A, 6,8 is for B, and 2,2 is for D. Knowing that becomes very handy. If we look at this diagram here, which can be just a sketch, what it means is our origin is somewhere here. And each box here might be in 2 units. Therefore, we can get the position vector 0,4. If we look at point A there's no change in the x-axis, and in the y-axis we've got a change of 4 since one box is 2 units. Now, having that we know about the triangle law of addition, if we want to find AB and BD, we can just remember one principle that comes from it. Finding AB can be found using just the position vectors of A and B. This is because them telling us we're dealing with position vectors simply means we've got a column matrix being formed from the origin to point A, a column matrix being formed from the origin to point B. Therefore, in this triangle that we form by joining point A, the origin, and B, we only have one missing vector, vector AB. And if you remember, we can find this using the triangle law of addition. If we keep the starting point and ending point constant and find a way in which we can move from A and get to B, we add those two vectors, we can have the value of vector AB. So we're just going to do that. As you can see, we're moving from A to O, so AB will be equal to AO plus OB. However, this kind of representation of this formula might sometimes be not commonly used. However, this is the principle behind this other formula. The only difference between these two formulas is this. In the first one, we switch the position of vector OA, or simply we make it negative. And by making it negative, what this simply means is we're moving in the opposite direction as the vector in the question was given. As you can see, position vector of A just simply means we're moving from O to A. Now, if we start from A and go to O, it means we're moving in the opposite direction. Therefore, we switch the letters there. Now, instead of switching this, the other thing that is easier for students is just putting a minus sign. AB is equal to OB minus OA. So this is thought like this. If you want to find a certain vector AB, you just subtract the position vector of the first letter from the second letter. This is done so that there are no mistakes when this formula is used. In this formula, a person must know that changing the direction in which we are moving will affect these values. However, for this second formula, that is not so much needed because there's already a minus included. Now, I'm going to use both ways to show that both of them will give us the same answer. As you can see, for the first one, I've used the vector OA, which will give us this column matrix. In the second one, I'll just add that minus. Now, you can see 0 plus 6 will give us 6. 6 minus 0 will give us 6. Minus 4 plus 8 will give us 4. 8 minus 4 will also give us 4. Therefore, these two methods can both be used to find the same answer. Now, your job right now is just to pause the video and try to solve for BD. I'm sure you paused the video by now. What you just need to do is pause the video again and check for the answer which is right on this screen. One of the things you need to know in the introduction of vectors is the magnitude of a vector. Magnitude of a vector just simply means we're finding the size of a vector. This size will usually be the length of that vector. This is the formula that is used. Saying x squared here just means the value of x is multiplied by itself, and then the value you get after you square x, you add it to the square of the value of y. Now, after you do that, the last thing that's remaining is you finding the square root of your sum. And the answer you find will be the magnitude of a vector. Let's say we had a vector AB. It could have been given like this or in coordinate form. The x in this form is the number on top and the y is the one below here. While for this one, x is the first and y is the second. So we just plug it into this formula. Our x will be 6 and our y will be 8. 6 multiplied by 6 is 36, while 8 times 8 is 64. If we add 36 and 64, we're going to have 100. Therefore, the number which we'll be trying to find the square root for is 100. 100 is a perfect square, so its square root is just 10. You should know at least the squares of the first 10 numbers. This is the magnitude of vector AB. Thanks for reaching till the end of this video. Now, try to get another past examination paper and see if you can locate any question on vectors with this information you've learned.